On today's episode, end of the line for Learjet, a big fusion project starts building hardware, and Texas freezes in the dark. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.tv today. Business aviation, well, it's long been dominated by that ultimate status symbol, the business jet. Bill Lear's pioneering Learjet 23 first flew in 1963, and the name Learjet eventually became synonymous with executive air travel. The brand is currently owned by Bombardier, and the Canadian firm has announced that in the fourth quarter of this year, Wichita, Kansas-based Learjet production will end forever. Company revenues from business aircraft reached $5.6 billion in 2020, and that's 3% year-over-year growth, but the firm is moving emphasis to their more profitable Global 7500 aircraft series, as well as the firm's Challenger business jets. The Wichita plant will become a specialized business responsible for special mission modification contracts and a new remanufacturing program for Learjet 40 and 45 aircraft. With over 3,000 aircraft delivered in the program, Bill Lear's tiny jet will be remembered as one of the most successful aviation projects in history. For years, fusion power has been widely predicted to be both the energy source of the future and about 30 years away from usable hardware. Several projects underway worldwide, however, promise to bring fusion power on realistic timescales, and none is bigger than the ITER project, a 35-nation collaboration that's building a large tokamak-type fusion reactor in the south of France. Construction began in 2010, with machine assembly starting in March of last year. The project is massive, requiring 1 million assemblies composed of 10 million parts built in member nation factories around the world, a major logistics challenge. Our project milestone was reached this week as critical component manufacturing began in Europe, specifically the vacuum vessel blanket that isolates the reactor from superhot nuclear plasma. At 𝗘𝗡𝗚𝗓𝗘𝗡𝗧𝗦 and Fusion Business Leadership, that's a partnership of Spanish firms Leading and Empresarios Agrupados, well, they'll build the first series of panels. Each group will have to set up and qualify a production line and make 30 panels as a pilot run. Future European contracts will be awarded after competition between the two groups. 10 years in the making, the panels themselves are engineering marvels. Each measures 1 by 1.5 meters and is coated with a 6 to 10 millimeter layer of beryllium armor bonded to a copper alloy heatsink, in turn mounted on a stainless steel structure. Of 440 panels required, approximately half are under the procurement responsibility of the European domestic agency Fusion for Energy. 215 normal heat flux first wall panels are designed for heat fluxes of up to 2 megawatts per square meter. China and Russia are purchasing 225 enhanced heat flux panels designed for 4.7 megawatts per square meter. The project is on an overall timeline for high-gain energy production that runs to 2035, but first plasma may be here as soon as December 2025. Last week's extreme cold in the continental U.S. resulted in widespread power failures, particularly in Texas, where 2 million homes were without power. According to the Electric Reliability Council of Texas, the independent system operator that manages electric power for 26 million Texas customers, 10,500 megawatts of customer load was shed at the worst of the emergency. ERCOT reported outages were caused by failures at generating stations across all fuel types, from fossil fuel to wind power, due to cold temperatures and icing conditions. Further outages were caused by a sudden increase in demand as Texans raised thermostats to stay warm, resulting in rotating blackouts as utilities struggled to restore systems. The Texas power infrastructure was not designed to accommodate extreme cold, unlike oil and gas delivery systems designed for operation in states like North Dakota or Alaska. Alternate energy sources such as wind turbines and solar are similarly vulnerable to extreme weather in the south. Both green energy policymakers and fossil fuel industries point to the outages as evidence in support of their systems, but with much of the continental U.S. affected by severe weather, it's unclear how either green energy or fossil fuels can help in extreme weather events such as this. While sub-freezing weather is rare in Texas, regulators, Washington, and electricity consumers are watching to see if the frequency of extreme weather events will force a redesign of major power systems in the south. We'll keep you posted. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For deeper engineering content, visit engineering.tv for exclusive shows like Manufacturing the Future and Designing the Future not found on our YouTube channel. Thanks for watching.